Recovery from deadlocks. When a detection algorithm determines that a deadlock exists, we must employ some recovery scheme. There are two recovery approaches that can be used to recover from a deadlock situation. The first of these approaches is inform the operator and let the operator deal with the deadlock manually. So in this case, human operator will be informed, and this operator, he will deal with the deadlock manually. The second approach is system recovers from the deadlock automatically. In order to recover deadlocks from the deadlocks, system has two options. Process termination, that is about one or more processes to break the circular wait, because the processes which are in deadlock state, they have a circular wait condition. This is one of the necessary conditions that must exist if there are deadlocks. So process termination will involve aborting one or more processes to break the circular wait condition. And once this condition has been invalidated, the deadlocks situation will be removed from the system. The second option that system can use is preempt some resources. These resources will be preempted from one or more of the deadlocked processes. Process termination. Process termination means eliminate deadlocked processes by aborting. The processes which will be terminated, system reclaims all resources allocated to these processes. Process termination has two options. The first option is abort all the deadlocked processes. So all the processes which have been in the deadlock state, all of these processes will be terminated. The second scenario is abort one process at a time until the deadlock is eliminated. So under this option, only one process will be terminated, and we will check whether the deadlock has been eliminated or not. If there is still deadlock in the system, then we will abort the next process. We will keep aborting the process one at a time until the deadlock is removed. As far as aborting all the deadlock processes is concerned, this is an expensive approach because the processes which will be aborted, these processes, they might have been computing for a long period of time. And might be these processes are near to completion. And if we abort all these processes, then it is an expensive solution because we have to restart these processes once the deadlock is broken. Whereas the second approach, it incurs considerable overhead. Since after each process is aborted, a deadlock detection algorithm must be invoked to determine whether any processes are still deadlocked. So every time we abort a process, we have to invoke the deadlock detection algorithm. This algorithm will ensure whether system is still in deadlock state or not. In case of partial termination means if we choose to abort one process at a time. In this case, which processes should be selected for termination? Because there are a number of processes which might be in the deadlock state. So, who should be the victim? Which process should be aborted first? The answer to this question is about a process that will incur minimum cost. The cost can be defined using various parameters. Cost might involve the priority of the process, or it might involve that how long the process has computed, etc. Process termination. There are many factors that may affect which process will be chosen as a victim. These factors include priority of the process, how long process has computed, and how much longer to completion, resources the process has used, the resources that are required for the completion of this process, how many processes will need to be terminated, and finally, is the process interactive or batch? Resource preemption. This is the second approach that system can use instead of terminating the processes. In resource preemption, system will successively preempt some resources. Preemption means it will take resources back from the deadlocked processes and give these resources to other processes until the deadlock cycle is broken. In resource preemption approach, following issues need to be addressed. The first issue is selecting a victim, that which process will be the victim, that from which process we will preempt the resources. Again, our objective should be to minimize the cost. We will choose a victim in such a way that will incur minimum cost. Cost can include the number of allocated resources, that how many resources have been allocated to this victim process, or cost can include the execution time, that is how long this victim has been executing in the system. The second issue is rollback. Rollback means before we preempt the resources from the process, we will roll back this process to some safe state so that process could be restarted from the state once the deadlock has been removed. However, in order to roll back a process, we must save necessary information while the process is executing. Because in the absence of this information, we cannot roll back a process to some safe state. Generally, system will roll back the victim process to its initial state. In other words, this process has to restart its execution from the point zero. The third issue is starvation. Starvation means that same process may always be picked as a victim. That every time there is a deadlock in the system, we may choose the same process as a victim to break this deadlock. How we can deal with starvation? We can include number of rollback in cost factor. That is, in while deciding which process should be selected as a victim, we can take this parameter, that how many times this process has been rolled back already.